When you think of an MRI, you probably picture a single static image of the brain, right? A snapshot. But what if we could turn that snapshot into a movie, a continuous living story of a patient's health unfolding over years? Well, that's the huge shift in medical imaging we're going to dig into today. This is the big question, isn't it? Especially for doctors who are treating diseases like multiple sclerosis. The illness can creep along silently for months or even years. A single scan, it'll show you what's happening right now, but it doesn't really tell you how you got there or, more importantly, where you might be going next. So, before we jump into the really cool solution, let's first get a handle on the problem. Why isn't our current way of doing things good enough? Well, it turns out we've been operating with some pretty serious blind spots. Okay, so let's take someone with MS. The standard practice is to get an MRI every 6 to 24 months. And this is absolutely crucial to see if the disease is getting worse or if a new treatment is actually working. But here's the thing. Every single time, a radiologist has to sit down and manually, with their own eyes, compare the new scan to all the old ones, hunting for tiny, subtle changes. And this right here is the core of the problem. The way things are now, the system treats every MRI scan as a totally separate event. It's like it has amnesia. It has no memory. So when a brand new scan comes in, it's like starting from scratch, forcing a doctor to manually hunt for differences between these incredibly complex images. So what we have is this massive gap. On one side, we're stuck in this world of manual review with one-off scans and data that has no memory. But what we really need is an automated system that connects all the dots, one that weaves a continuous story and can actually track the state of the disease over time. And this problem, it's not getting any smaller. In fact, it's getting bigger, fast. Medical imaging data is just exploding. It's growing by about 30% every single year. Most hospital IT systems just weren't built for that kind of data flood, and they definitely weren't designed to power the kind of AI that we need for the future. All right, so what's the fix? Well, it takes a completely new way of thinking. We need to stop seeing MRIs as just pictures and start seeing them as infrastructure. It's a pretty radical idea, and it totally reframes the entire problem. So this is the big idea. MRI as infrastructure. Instead of having a digital folder stuffed with separate image files, imagine a patient's entire history of scans as one single evolving data stream. It becomes a living record of their health that just gets updated with every new scan. So how in the world does this actually work? Well, it really comes down to three key innovations. First up, you've got version control. Think of it like track changes, but for the human brain. The system automatically finds the exact differences between the new scan and the old ones. Then there's a metadata layer, which adds all this crucial context, like what treatments a patient is on or what symptoms they're feeling. And finally, you have data harmonization, which makes sure that scans from different machines, maybe even from different hospitals, are all tuned to the same standard. So you're always comparing apples to apples. Okay, so that's the theory. But what does this actually look like as a real automated system? Let's take a look at how it all connects. Here's the whole pipeline in a nutshell. All of these different scans, taken at different times, flow into the system. They get harmonized and perfectly aligned, creating this unified timeline of the patient's brain. The researchers call it a longitudinal state layer. And this is what transforms a simple folder of images into a single intelligent record. It opens the door for some seriously powerful new analysis, like tracking how a specific region of the brain has changed over years and years. Now, building this whole thing in the cloud, that's what makes it a total game changer. For one, it can scale to handle that massive 30% growth in data we talked about without crushing hospital IT departments. Of course, it's built on a super secure, HIPAA-compliant foundation, so patient data is protected. And, maybe best of all, it means an authorized specialist can securely pull up a patient's entire MRI story from anywhere in the world. Okay, so that's the tech. It's really cool. But let's get to the important part. What does this actually mean for doctors, for researchers, and most of all, for patients? This is where it all comes to life. This kind of innovation, it creates this incredible ripple effect. It's not just one group that benefits. We're talking about the hospitals and the clinicians on the front lines, the researchers and AI developers building the future, and even the pharmaceutical companies trying to find new cures. It really is a win-win-win. So for clinicians, they get automated alerts flagging any new disease activity. This means they can make faster, more informed treatment decisions, and it helps reduce that feeling of burnout. For researchers, they get these beautiful, perfectly curated data sets that are ready for AI, which just dramatically speeds up the whole discovery process. And for pharmaceutical companies, they can run much more efficient clinical trials, which saves a ton of time and money and gets new drugs to patients way faster. You know, the team behind this project, they summed up their mission perfectly with this quote. It's all about turning imaging infrastructure from a clinical bottleneck into a clinical enabler, a tool that actually pushes care forward instead of holding it back. And you have to understand, multiple sclerosis, that's just the beginning. This entire framework is really a blueprint for the future of how we understand brain health. So MS was the proof of concept, right? It showed that the model works. But now, just imagine applying this exact same approach to track brain volume loss in Alzheimer's patients, or to combine all different kinds of imaging to get a much richer picture of Parkinson's disease. It's a powerful model for understanding how any brain changes over time. At the end of the day, what this is all about is a huge shift in medicine itself. We're trying to move away from being reactive, treating problems only after they show up, to being proactive, predictive, and truly personalized. It's about using your own unique data story to deliver medicine that's tailored just for you. And that leaves us with one last pretty powerful thought. We are heading into an era where our medical data is no longer just a scattered record of the past. It's becoming a continuous story, a story that's still being written. And that story might just hold the key to predicting and maybe even shaping the future of our health.